Hi, this is Dr. G. Bailey. In this video, we're going to go through some past IB exam papers focusing on paper 1, which is all about multiple choice, but these multiple choice only focus on topic 4.3, which is all about carbon cycle. So let's go ahead. Make sure to read the question at least 3 times, and please read A, B, C, D in the test because sometimes you might find that C and D are very close to each other. So don't go and just answer the first one you think it is. Always make sure to read all of them before making your decision. So here says the first question, how is peat formed? Now peat, there is very important things that you have to remember about peat. 1, it will always be partially decomposed. So if you remember that is always partially decomposed. 2, that it has an acidic environment. And 3, it is anaerobic. If you find these 3 words combined, then automatically that is the answer for peat. And you will see a lot of questions asking about peat in the IB exams. I see it comment very often about it. So when you have these 3 words, partially decomposed, acidic, anaerobic, if they're combined together, I guarantee that is the right answer. And we can always include another word here if you want. Sometimes it happens, which is, it says waterlog. So when you say waterlog, anaerobic, acidic, and partially decomposed, automatically, if these 4 are in the same sentence, I guarantee you that's the P. So the first one says metagenic archaeans under anaerobic and acidic conditions in deep VC vents. Now here, it says anaerobic and acidic, and many students fall into the trap. But metagenic does methane, so that it is wrong. Remember, metagenic has nothing to do with peat. Next, from partially decomposed, you can already see the first sentence here, the first words that hits organic matter under anaerobic, that's the second word, acidic in conditions in waterlogs. See, B right here nailed it. It answered partially decomposed, acidic, anaerobic, and waterlog, the 4 things that you find for peat. So I will continue reading the rest, even though I can see that B looks like it's the right answer. Here says a porous limestone under high pressure, aerobic. Oh, you already said aerobic, so done. From bituminous coal under high pressure, anaerobic acidic conditions below the ground. But it says below the ground, and it doesn't say anything about waterlogs. And there's nothing about high pressure when it comes to peat in this case. So it's not D. So obviously the answer is B. So once again, having these 4 words in your head about peat, you will always be able to answer right. Here's another question that I placed because this is showing how peat is very common in the IB exam. Here says, what favors the production of peat? So the presence of organic matter is true, anaerobic conditions true, acidic condition true. Now many students say, oh, one cannot be true because it doesn't say dead. No, it still is an organic matter. It didn't say it's living or dead, but it's still part of it. So the answer here is D, all of it. Next, what condition favors peat formation? Did you just see it's 3 questions on peat? Because yes, peat is a very common question for 4.3 in multiple choice. So make sure you know it very well. So we want to try to make peat formation. We already know that it has to do with anaerobic and acidic. So that means A is gone and D is gone because again, both of them are aerobic. Next, you have to know that it's a waterlog, so it has to be wet. So it cannot be dry. So that means C is out of the base. And then, of course, if you didn't know about the wet and dry, you can also know that it's not basic, right? It has to be acidic. So obviously the answer is B. So once again, knowing those 4 words, you get the peat very easily. Next is diagram shows a version of carbon cycle. What is indicated by the numbers? So you got to look at this chart and you can start to make some of, like recognitions here. For instance, okay, this you can see that is atmospheric CO. Okay, fine, that's the atmosphere. Then you see a tree here. And then you see a line next to the tree with the number 3. So obviously, if CO2 here is going towards the tree, this can only be photosynthesis. So I'm not even looking at the multiple choice. I'm still digging, analyzing the question, the graph, before I even get to the multiple choice, because that saves time too. And then I can see that the tree is showing an arrow towards the animal. So most likely here, it is oxygen that is given to the animal. The animal is taking that oxygen as well as glucose, if you want to say here, because it's a carbon cycle. Now the animal here, you can see there's a feces of the animal, and the feces of the animal is basically going down towards being coal, oil, and gas. Rest, that's when the animal is actually pooping, his poop goes to the soil, goes down. But it also shows an arrow of the animal going towards itself. That means this is where decomposition is happening, right? It's when they die and you can't have the saprotrophs digesting them. And then living organism here also has from dead animals going down. So it's also decomposition for sure. And then we have dead animals here having an arrow in this direction. Of course, when you have decomposition, when the animals are decomposed, what does the animals do that gives out whenever they eat dead animals? They release CO2 back up. So what else do we have here that we can think of? What else? This one right here, which the coals are coming this way, that would have been combustion. So I kind of analyze. Now that I have done analysis, let's look at the questions. Here says to educate you the numbers. So we're going to look at number one. Number one here, which is this one, it says death of consumers, self-respiration, saprotrophs, self-respiration, and consumers. Since we know it's a decomposed cannot be consumers, right? So it cannot be this. And it's definitely not the death of the consumers because it's already dead, the animal, so it cannot be this. So just by looking at this, I already know that this is the answer, right? Self-respiration, because decomposers basically are eating the dead animal. As they do this, they're doing self-respiration. When I say self-respiration, it's like eating food. So the bacteria or the decomposer is eating the dead animal and releasing CO2 back to the atmosphere. So I know the answer will be C, but I still can continue. Then I have number 2 here, which is also decomposed, but these turning into oil gas and coal. Now, what is that turns into oil gas? That means when the living organism, since we have 2, right? We have decomposed here and here. The only difference is this one is a fully decomposition and this one is a partial one. If it's a partial one, that means it turns into peat, and then peat turns into these guys, so it's incomplete decomposition, which makes sense. And then number 3 is photosynthesis, and it has that. So you can see that C is the right answer. So it's one thing is very important is to remember that when a bacteria is eating a dead animal, bacteria is also releasing CO2 to the air, because eating a dead animal is the same thing as doing cell respiration, which is releasing CO2. So moving on to the next question. Here, methogens produce methane gas. What is the gas converted to in the atmosphere? So here is where you have to know the equation of methane. So that we have methane, and whenever methane is produced, if it reacts with oxygen, eventually it will release CO2 plus water vapor. So this is the main equation, and you have to know this by heart. If you know this, then you can answer the question very easily. So what is the gas converted to? That means this, when it reacts with oxygen, it releases these two into the air, water vapor and CO2. So we can find here it's not this one, it's not this one, it's not this one. It is definitely this, carbon dioxide and water, so it's D. Now, the sad news is, what if you don't remember the equation? How would you solve for this? If you don't know the equation, then you have to put a little bit of gassing going on here. First of all, we gotta say that oxygen is not released into the atmosphere by, for instance, a bacteria, right? Think about it. This is a bacteria. Otherwise, you will see a plant name. You don't see a plant name, so it can be this one. And then ethanol usually is released by a plant. A methogen does not look like a plant. And then ozone here has nothing to do with anything related in topic 4, so that kills. So that leaves you with D again. So this is by chance, by gas. Otherwise, make sure you know the equation, which is methane reacting with oxygen turned to CO2 and water. Next question. Here shows a diagram of carbon cycle. So what do we have here? We have we have green plants, and we have carbon dioxide in the atmosphere and dissolved in water. Let me take off this so it can be clear for me. Now the question says, which 2 processes correspond to the label arrows? So when we look at this, you can see that the arrow from the green plant is going towards the fuel. So what exactly makes a green plant turn into fuel? This can only be if the plant is dead and it's been decomposed eventually. And in this case, would have been breaking it down. So because I'm looking at the words here, catabolism, combustion, anabolism, respiration, that means the plant will be broken down. I think this will be catabolism for sure. And then the fuel here will be going to the atmosphere. So the fuel going to the atmosphere releasing CO2, I know that this is combustion for sure, right? Because if you remember from the carbon cycle, fossil fuels being burned with oxygen will turn into CO2, so that's combustion. Next, I have green plants here. Somehow they're releasing CO2 to the atmosphere. Now, we know that green plants can also do cell respiration. So remember, cell respiration is not just for animals. Plants can also release CO2. And then here we have CO2 coming into the green plants, which that means it can be photosynthesis, right? Because photosynthesis is when you absorb CO2 inside. So let's see here what we have. K is combustion. No, it's not true. J is anabolism. Where's J? Anabolism means joining them together. And it's not. The fuel is being broken down through combustion, so it cannot be B. And then here J is combustion, which makes sense. And K is cell respiration, which makes sense, so it can be C. J here is anabolism. No, because it's being broken down, so this is out. So the only answer is C. So you really have to know about the carbon cycle. That means the photosynthesis, cell respiration, combustion, deforestation, decomposition, anything else I can think of, photosynthesis, respiration, combustion, decomposition. Yeah, these ones not counting deforestation or acidification. You have to know the carbon cycle really well to be able to go through this graph. The next question here says, what describes the possible cause of negative carbon flux? That means the carbon is coming out into the atmosphere due to decrease of occurring in the forest ecosystem. So when I say the word negative carbon flux from the atmosphere, it means I am reducing the amount of CO2 in the atmosphere. That's what it means, negative carbon flux. That means less carbon dioxide in the atmosphere. So how can I reduce the carbon dioxide in the atmosphere? The only thing I can think of is about the trees, right? Because what do the trees do? The trees absorb the CO2 in order to make glucose through photosynthesis. So if I put more trees in the soil, more trees will absorb CO2. That's the only way I can think of CO2 being reduced in the atmosphere. So let's look at the option. The tree grew more, so fix it more carbon dioxide. So when the word fix it, the word fix it means here is that I'm using CO2. Eventually, it will be fixed. That means add more carbons in there in order to become glucose, which is C6H12O6. So you can see more carbons are fixed. That means you're adding more carbons. When I say the word fixed, that means I'm adding more carbons. So that wouldn't make sense because I'm putting more trees. So A would have been the answer, but I still have to look at B, C, and D and make sure that these ones are for sure not. There was more respiration by soil organism. No, because if you do more cell respiration, that means you release more CO2 to the air. So it can't be that. There was more burning of the forest. If you're killing the trees, that means less oxygen is being, carbon dioxide is being absorbed, which that means more CO2 will stay in the air. Nope. There was more decomposition of leaf litter. No, because even the bacteria, when it's eating the leaf, right, when it's eating it, it's releasing CO2 into the air. So it's definitely not these all, and it has to be only A. So again, I already knew that it's A, but it's important that you read the other ones because sometimes there might be two answers that are very right, but one is more specific. So moving on to the next question here, it says, in the diagram, which of the processes labeled A to D transfer the largest mass of carbon per year in a woodland system? So we're talking about a massive amount of carbon moving. What is it moving? Is it moving from a green plant here to the atmosphere? That would be known as A. Or is it moving from the atmosphere to the green plant as B? Or is it moving from the green plant right here into a decomposer as C? As well as the animals, you can see, right? The animals and the plants moving to the decomposer. Or is it the green plants moving into the plants the green plant moving into the animals through photosynthesis. So which one of these, A, B, C, D, where you have the largest movement of carbon? So in here, you can see that it doesn't tell you anything, right? Numbers, nothing. So this has to come from background information. So which one of these will you have the largest amount? Now, some students say, oh, because here it's a bigger box compared to the other four here. See, it's smaller, 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 and smaller, right? Ironically, by luck, they will get the right answer simply because, oh, it's a big box, so that means there must be going much more to the green plants than any others, and they will say that the answer is B, which ironically, it came out to be true. B is the answer. But the truth here is if you think about this, you having the food sending a lot of CO2 here. You have the green plant sending a lot of CO2 here. You have the animals sending a lot of the CO2 through cell respiration and decomposer too. So that means you had a large chunk of CO2 being sent to the atmosphere. But it's a combination of all of these, 1 and 2 and 3 and 4, all of them sending, even 5 here, all of them sending here. So this guy has the biggest storage of CO2. So most likely that storage is going towards the plant. So that's why the biggest flux of carbon going on will be in this direction. It can't be just this. It cannot be, for example, this one here, the A. Why? Because the green plants alone does not make more than the other ones, neither the decomposers and neither just the animals. So it is the combination of all of them together in the atmosphere combined to send them all in direction of the plant. So the answer is B. Here says, what material is formed from organic matter and is not fully decomposed? And this I put it here just to make sure you remind yourself again. It said the word not fully decomposed. So that means partially decomposed. And then it gave you the word acidic and the word waterlogged. Automatically, peat. You should even look at the other answers because automatically it is peat. This is, again, not when it says partially decomposed, acidic, anaerobic, waterlogged, those 4 words, automatically it is peat. And that's pretty much it. You can see that 4.3 has a lot of questions on peat and carbon cycle. These are the 2 things you must really know for 4.3 in order to nail any questions when it comes to section 4.3.